Welcome back in lecture series on topic chemical thermodynamics. In last video, we have studied enthalpy of phase transitions such as enthalpy of fusion, enthalpy of vaporization, enthalpy of sublimation like this. And today in this lecture, we will study enthalpies of atomic and molecular changes. So there are three types of enthalpies of atomic and molecular changes. First one, that is ionization, enthalpy of ionization, enthalpy of atomization, and enthalpy of solution. So let us see first enthalpy of ionization. It is denoted like this: delta ion H. And enthalpy of ionization is the enthalpy change that accompanying the removal of an electron from one mole of gaseous atom. Remember here, that is, electron is removed from gaseous atom. It is only from gaseous atom and not from solid or from liquid atom. So enthalpy change that accompanying the removal of an electron from one mole of a gaseous atom. For example, see here, this is an atom and this one is the electron in the outermost shell. To remove this electron, how much amount of energy is required? That is enthalpy of ionization. So, and to form a gaseous ion, positively charged ion. For example, see here. Here, 1 mole of gaseous phase sodium atom when ionizes and gives 1 mole of gaseous phase sodium ion, then how much amount of energy is required? 494 kilojoules of heat is required. So 494 kilojoules of heat is required to ionize 1 mole of gaseous sodium atom, and that is what? Enthalpy of ionization of sodium. Another example of this, that is calcium. 1 mole of calcium atom in a gaseous state when ionizes and gives calcium ion plus 1 ion in a gaseous state, then amount of energy required is 590 kilojoules. That is the enthalpy of ionization, and it is called as the enthalpy of first ionization enthalpy. It is called as a first ionization enthalpy, as this is the energy required to remove the first electron, first outermost electron. When second electron is removed from gaseous calcium ion to form calcium plus 2 ion in a gaseous state, then amount of energy required is 1150 kilojoules. That means here it is known as second ionization enthalpy, as it is the enthalpy or heat energy required to detach the second electron from monopositive calcium ion, gaseous calcium ion. And here this value shows you that the second ionization enthalpy is greater than first ionization enthalpy, and this is due to as here the calcium atom in gaseous state is neutral atom, and in case of neutral atom, the attraction between the outermost electron and nucleus is less as compared to outermost electron and positively charged calcium ion, as its size is small. The attraction is more, and here if you compare the size of these two, that is calcium atom in a gaseous state and calcium ion in a gaseous state, monopositive ion in a gaseous state, then size of calcium ion is smaller than calcium atom, and this is due to this second ionization enthalpy is greater than first ionization enthalpy. And reverse of this is electron gain enthalpy. It is denoted as delta EGH, and it is enthalpy change when 1 mole of gaseous phase atom of an element accept electron. 1 mole of gaseous phase atom accept electron to form gaseous anion. See here, it is a chlorine atom suppose, and it accepts one electron and form chloride ion in a gaseous state. Then whatever heat is released, remember here most important point, that is sign. Electron gain enthalpy is reverse of enthalpy of ionization process, and ionization process is endothermic. In that energy is required, but here electron is gained, so energy is released. So chlorine atom in a gaseous state when accept electron, 1 mole of chlorine atom in a gaseous state when it accept electron, then how much amount of heat is released? Minus 349 kilojoules. This much amount of heat is released when 1 mole of chloride ion in the gaseous state is formed. That is called as a electron gain enthalpy. The second type of enthalpy, that is enthalpy of atomization. It is denoted like this: delta atom, ATOM, Definition of this is enthalpy change that accompanying the dissociation. Remember here the most important word, enthalpy change that accompany dissociation of 1 mole of gaseous substance into its atoms is the enthalpy of atomization. For example, see here chlorine molecule. When it dissociates, gives you 2 chlorine atom, and enthalpy of atomization of chlorine molecule is how much? 242 kilojoules, as it contains only one single bond, chlorine bond. But here methane in a gaseous state, when it dissociates and gives you 1 mole of carbon in a gaseous state and 4 moles of hydrogen in a gaseous state, then amount of heat required is how much? 1660 kilojoules, as it is what? It contains, that methane contains 4 carbon hydrogen bond, and number of bonds are more as compared to chlorine, so enthalpy of atomization is more in case of methane as compared to chlorine. So suppose this is the chlorine molecules, then the energy required to separate these atoms, chlorine atoms, like this, is known as enthalpy of atomization. Now the third one, that is enthalpy of solution. It is noted like this: delta solution H. And enthalpy of solution is the enthalpy change in a process when 1 mole of substance is dissolved in a specific, important is what? Dissolved in a specific amount of solvent. 1 mole of substance is dissolved in specific amount of solvent to form a solution of a particular concentration, is known as enthalpy of solution. So see here, when sodium chloride, 1 mole of sodium chloride in a solid state, it is dissolved in a solvent such as water, then it gives you solution, that is when 1 mole is dissolved, you will get 1 molar solution. When dissolved in 1 liter, then you will get what? 1 molar solution. And during this, what the heat required, for this heat required is how much? 4 kilojoules per mole. Or another example, when 1 mole of ammonium chloride is dissolved in 1 liter water, then it forms 1 molar solution of ammonium chloride, and during this heat required for this is 16.4 kilojoules per mole. So these are called as a enthalpy of solution of sodium chloride or ammonium chloride. It can be defined like this also: enthalpy of solution at infinite dilution is the enthalpy change when 1 mole of a substance is dissolved in infinite amount of solvent. That means if the solvent is in excess and further addition of the solvent does not produces any heat, or a further dilution does not changes the enthalpy of solution, then that enthalpy of solution is known as enthalpy of solution at infinite dilution. It is known as enthalpy of solution at infinite dilution. And at infinite dilution, interaction between the ion is very less, or it is negligible, and therefore there is no change in the enthalpy. And this ionic enthalpy of solution can be explained with the help of ionic compound. Now when ionic compound is dissolved in water, then dissolution of ionic compound takes place in two steps. First step is the separation of ions from the molecule. You know that in ionic solids, ions are held together by the strong attractive forces, interionic forces between them, and to break these forces energy is required, and this energy is called as what? Crystal lattice enthalpy. So first step during dissolution of ionic compound is what? Separation of ions from the molecule. And in separation, what happens? Solid breaks up to form ions in a gaseous state. For example, this is Mx is the solid, and when it is dissolved in a solvent, then it gives, the first step is what? You have to separate these ions from this solid. And in this, as it is an ionic solid, the strong attractive forces are present between the this positively charged ion and negatively charged ion, and first step is to separate these ions in a gaseous state. And to separate this, to break the bond between these two, some amount of energy is required, and that energy which is required, or during this separation process some amount of heat is required, and that heat is known as what? The lattice enthalpy, crystal lattice enthalpy. So enthalpy change for this step is known as what? Crystal lattice enthalpy. See here, suppose this is the crystal of sodium chloride. Now in chlorine atom and sodium atom, this green colored atom are of chlorine and blue color atom of the sodium. Now there is a strong attraction, as it is a ionic solid, there is a strong attraction between these cations and anion, and to separate these chloride ions and sodium, positively charged sodium ion, some amount of energy is required, and that is called as what? Lattice energy. It is denoted like this, delta LH, that is called as a crystal lattice enthalpy. And this crystal lattice enthalpy is always positive. Remember that this energy is required. Energy is it is not released, it is required, and therefore it is necessary to break these ions, to break these bonds and to separate these ions. So it is what? Crystal lattice enthalpy is always positive. Now crystal lattice enthalpy means, crystal lattice enthalpy of ionic compound is the enthalpy change which occurs when 1 mole of ionic compound dissociate into its ions in a gaseous state. That is called as what? Crystal lattice enthalpy. And reverse of this, for example, see here, Mx solid gives Mx M plus ion in a gaseous state and X minus ion in a gaseous state, and during this whatever amount of heat is required to take place this process is known as what? Crystal lattice enthalpy, delta LH. For example, sodium chloride in a solid state, when it forms sodium ion in a gaseous state and chloride ion in a gaseous state, then heat required to separate this is how much? Plus 787.6 kilojoules. This much amount of heat is required. Or the oppositely charged gaseous ion, you know that in a crystal lattice, oppositely charged gaseous ions are held together by strong forces of attraction, and when it is formed, then heat energy is released. That means reverse of this process is formation of the crystal lattice, and therefore whenever sodium ion in a gaseous state plus chloride ion in a gaseous state, when they combine and form solid sodium chloride, then the energy released during the formation of solid sodium chloride is how much? Minus 787.6. That means the sign is reverse. Crystal lattice enthalpy, to separate the ion, it is how much? Plus 787.6, while during the formation of a solid sodium chloride from oppositely charged gaseous ion, how much amount of heat is released? Minus 787 kilojoules, 87.6 kilojoules. This much amount of heat is released. So in formation of solution, the first step is separation of ions, and second step is what? The hydration of the ions. But here we will study first how to calculate the crystal lattice enthalpy. Now crystal lattice enthalpy cannot be directly calculated, and the dissolution of the any salt or any compound depends upon the crystal lattice enthalpy. Smaller the crystal lattice enthalpy, more readily the dissolution of the salt occurs. And to calculate this crystal lattice enthalpy, you should know the enthalpy of sublimation of sodium, that is solid sodium to gaseous sodium atom, then enthalpy of ionization, enthalpy of atomization, and an electron gain enthalpy, and enthalpy of formation of a sodium chloride or any other salt, that you must know. And if you know these values, then you can calculate the crystal lattice enthalpy. So crystal lattice enthalpy is equal to enthalpy of formation minus addition of all these, that is enthalpy of sublimation plus enthalpy of ionization plus enthalpy of atomization plus electron gain enthalpy. See here, for example, for sodium chloride, if you want to calculate the lattice enthalpy, crystal lattice enthalpy of sodium chloride, then enthalpy of the formation of sodium chloride is how much? Minus 411 kilojoules, minus addition of this enthalpy of sublimation of sodium is 109 kilojoules, whereas enthalpy of ionization is 121. Enthalpy of atomization of chlorine is 496, and electron gain enthalpy is always negative. So electron gain enthalpy is minus 348 kilojoules. So if you add all these and subtract it from minus 411, then it becomes how much? Minus 790 kilojoules. This is the enthalpy of formation. But during the formation, lattice enthalpy during the formation of sodium chloride, and reverse of this is the energy required to separate sodium ion and chloride ion, and therefore the sign of this becomes positive, that is plus. Crystal lattice enthalpy of sodium chloride during dissolution is how much? Plus 790 kilojoules per mole. So second step in dissolution is hydration of ions of compound. Now the ions of compounds are hydrated with water. When any salt is dissolved, then the hydration takes place. That is, see here, the positively charged metal ion in a gaseous state combines with X moles of water, surrounded by X moles of water, and forms MH2X plus ion. So it get hydrated. This process is known as hydration of positively charged ion. Like that, the negatively charged ion surrounded by water molecule, Y number of water molecules, and gives you X H2Y minus. And both these processes are called as a hydration process, and enthalpy change during these two steps is known as enthalpy of hydration. It is called as what? Enthalpy of hydration. It is denoted as a delta HYDH, and the hydration enthalpy is always negative. Remember that here the bond between metal and water is formed, or negatively charged ion and water is formed. Therefore, enthalpy change for this step is always negative. What happens during hydration? See here. This is the, suppose water is the solvent. If water is the solvent, then it is called as what? Hydration. And if any other solvent is there other than water is there, then it is called as a solvation. It is also called as a solvation. So suppose this is the solvent, water is a solvent, then water is polar. That is, here oxygen has a partial negative charge and two hydrogen have partial positive charge. When sodium chloride is dissolved in water, then what happens? Sodium ion gets surrounded by the water molecule, and the big forces of attraction between sodium ion, and sodium is a positively charged, negative end of water molecule attracts the sodium ion, and it gets surrounded by, sodium ion gets surrounded by water molecule like this. And chloride ion is negatively charged, so positive end positive end of water molecule surrounds the chloride ion, and thus the sodium ion and chloride ions get separated. And during this process, some amount of heat is released, and that is called as a hydration energy. So enthalpy change during hydration is always negative. During this hydration process, enthalpy is negative. So like this, the hydration of any ionic solid takes place. Suppose this is the sodium chloride. Blue atoms are of sodium, green atoms are of chlorine. Then when it is dissolved in water, then sodium ion gets surrounded by negatively charged negative pole of water molecule, and chloride ion is surrounded by positive pole of the water molecule like this, and the salt get dissolved in a water. So enthalpy of solution, therefore it is a sum of crystal lattice enthalpy and enthalpy of hydration. So enthalpy of solution is equal to crystal lattice enthalpy plus enthalpy of hydration. For example, for sodium chloride, enthalpy, crystal lattice enthalpy is plus 790 kilojoules, and hydration enthalpy is minus 786 kilojoules per mole. So enthalpy of solution is equal to how much? The enthalpy, crystal lattice enthalpy plus enthalpy of hydration. So 790 minus 786, and that is equal to how much? 4 kilojoules. So enthalpy of solution of sodium chloride is how much? 4 kilojoules per mole. Like that, for KCl, enthalpy of crystal lattice enthalpy is 699 kilojoules, and enthalpy of hydration is 681.8 kilojoules. So enthalpy of solution of KCl is equal to crystal lattice enthalpy plus hydration enthalpy. So 699 kilojoules plus minus 681.8 kilojoules, and that is equal to 17 plus, sign is what? Plus 17.2 kilojoules. So crystal enthalpy of solution of KCl is how much? 17.2 kilojoules per mole. So thank you for watching.